DNA evidence from the hair and get DNA from the person's mother, which would be identical. So from this, we can say if these two are identical, the crime scene hair DNA and the mother's DNA, then we know that the person at the crime scene was either the mother or the son, or some relative on some maternal relative. So if we can say that it clearly wasn't the mother, or let's say the brother from the same mother, if we know that it could not be them, and we know the DNA matches the mother and him, then we know it's probably him, unless we can find some other maternal relative that we suspect. But again, it's certainly useful as evidence to point to where to go, or to even provide some kind of proof, maybe not perfect proof, to a person, to a suspect, that they were there at the crime scene. So because of all, it's difficult though. It's not the common form, and unless we need to do it, we're not going to do it. We're going to try to do other forms of identifying the suspect rather than use mitochondrial DNA. DNA is very sensitive. Even 18 cells, that's really a tiny amount. If you can get those, that's all that's needed to get DNA evidence. As mentioned in an earlier lecture, we can multiply this, and we can multiply to pretty much as many as we need. So even 18 cells are all that's needed to prove that DNA is a match, or to get the DNA, or to have useful DNA that we can match and therefore identify the source of the DNA. It's possible to do it even with 9 cells, but in courts they don't really like that. It's a little too little. They prefer having 18 cells. And more than 18 cells, or 18 or more cells, that's admissible in court. But 9, they suspect, well, maybe there were problems with so small, errors, or whatever the reason is. Even though it can be done. But to be useful for proof in court, we want 18 cells. Just by touching something, you're going to probably deposit at least 18 cells. So this is called touch DNA. If a criminal touched or wiped a surface, we should start looking at it. Try to get DNA evidence from it. Let's say a wet swab of that surface. Wipe it around and pick up that DNA. Even though the person just touched it, if you can pick it up, you have evidence that person was there. Just get the DNA, get the DNA profile, get the suspect's DNA profile, and you can prove that the suspect was there at the crime scene. This is true for anything they touched. A weapon, like a knife. He handled a knife and he left the knife behind. Wipe that knife down and see if you can get DNA from it. I mean, if he wore gloves, okay, it's a problem, but very often they don't wear gloves wherever they go. They might have used a toothpick and thrown it out. Well, you don't use a glove in your mouth usually. They might have worn a mask that they threw away. You can get the mask, get the DNA from let's say they wore, a Halloween mask. So they threw it away. Get the DNA from the Halloween mask and try to get the DNA from the suspect. If you can prove that they're the same, well, there you go. You have connected the person who, the suspect, to the mask worn at the crime scene. The collecting DNA, it comes with its own difficulties. Again, it's certainly very, very useful. We certainly want it. We want it very much. It's so useful. It's biological. It's a biological form of evidence, and because of that, it should be. We might be warned it might be infectious. I mean, the person might have touched a certain area, or spat in a certain area, or coughed in a certain area. We want the DNA from there, but we don't want to get infected by whatever that person might have had. He might have had nothing, but he might have been infected. We want to avoid that. So whenever we collect DNA, we have to watch out. First of all, wear gloves for. We don't want to get infected, so we don't want to touch things with gloves. We also don't want to put our DNA on in that area, but that we'll talk about soon. Wear a face mask. Again, you don't want to breathe it. If there are germs coming out of there, we don't want to breathe it. Lab coat will cover our body and our clothing because, let's say we're wearing short sleeve shirts. A lab coat does not have short sleeves if it's made well. So you don't want that to touch your arms or anything, again, to infect your arms. So again, the lab coat will cover everything. Eye protection. Also, again, the eyes can be sensitive, and we all want to wear eye protection. It does help shield from getting infected. once that's taken care of, we also want to avoid the evidence, being destroyed. It's biological evidence. That means bacteria can very easily get to it and try to destroy it, or even mold. So we want to preserve it well. So we use paper containers. It should be dry, but it should paper containers. When things air out, bacteria and mold don't grow that well. So we use paper containers so it can air out. With swabs, they have to be air dried also. If they're wet, they can pick up things from whatever's around it. We don't want that to happen. We want these things to stay pristine, uncontaminated. What we want is to preserve it, put in paper containers, not sealed plastic ones, because we want the air to circulate. Also, it should not be frozen. When you freeze it, it's called crystallizing the water, and when you crystallize it, it can damage cells. It might even damage DNA. So if we have it, we refrigerate it to keep bacteria from all kinds of things from growing in it. We don't want that to happen, but we don't freeze it. However, if you find biological evidence in soil, let's say you spat into the dirt or something like that, in that case, we have to freeze it, because microbes we know they're all over the dirt, and they're going to get all over the DNA and all over the cells. So in that case, we want to avoid that. So now we have to freeze it to stop the microbes in their tracks. So in that case, we have to weigh one possible damaging of DNA to another against another. The freezing versus the microbes. As it turns out, the freezing damages less than the microbes would damage if it's in soil. So in this case, we can use plastic or glass containers, and we don't have to worry too much about it air drying and growing mold, because if we're freezing it, that's not a problem. We also have to worry about contamination. The people at the crime scene, if there's DNA there, they must use gloves. Sometimes even 2 layers of gloves for added protection against their own DNA touching it, their own hands touching it, or skin cells flaking off their own hands. So make sure to wear 2. Sometimes you might have to wear 2 gloves depending on the situation. Wear a face mask. You don't want, because you're going to be looking at the thing, presumably. You're going to be looking at what you're doing. We don't want anything to. We don't want you to breathe on it and possibly deposit your own DNA onto the crime scene DNA. That just confuses things. And try to avoid sneezing anywhere near or coughing anywhere near where the evidence might be. Wear a lab coat again. Your skin cells can flake off. Your lab coat will cover your arms, will cover a lot of you, so that anything on you will not end up on the crime scene and contaminate the DNA found at the crime scene. Now remember, DNA. Let's remember, DNA. A little touch will cause DNA to end up there. Now that's great to identify criminals, but the problem is that we have to avoid ourselves touching or getting too close to or breathing on the crime scene, because then our DNA will be there, and we don't want that to happen. It'll just make things harder to analyze. Use only tweezers. Don't use your hands. Because again, tweezers don't have DNA, they won't do anything. Use different tweezers for every piece of evidence, unless you want to sterilize or wash it in between. But usually you just use 2 different tweezers for 2 different pieces of evidence. Again, we're trying to avoid contamination. It's easy to contaminate DNA evidence because DNA can exist in minor, tiny amounts. So a little contamination might contaminate a lot. Anyway, also use hair and shoe covers. You don't want your hair to end up there. We don't want, and it's possible to pick up, you step in something, your shoes might pick up some DNA. So, cover your shoes or